Right now, at this very moment, Earth is being bombarded by one of the most powerful solar storms in over 2 decades. This is not a drill. A G4 geomagnetic storm is already underway, with the potential to escalate to G5, the highest level possible. For the first time since Halloween 2003, an S4 solar radiation storm is hitting our planet. That is 23 years. And here is what that means for you tonight. Nearly the entire United States could witness the Northern Lights. Yes, even if you live in Texas, Georgia, or Florida. But before you get too excited, you need to understand something critical. This storm is already causing real problems right now. Radio blackouts near the poles, GPS disruptions, aviation challenges, and the potential for power grid issues that could affect millions of Americans. Stay with me, because in the next few minutes, I am going to tell you exactly whether you will see the Northern Lights from your location tonight, what time to look, and why this storm is far more significant than just a pretty light show in the sky. But first, let me answer the question everyone is asking. Will I see the auroras tonight? The answer depends on where you live, and one critical factor I will reveal at the 30-second mark. Here is your first reward for staying with me. The best viewing time tonight will be between 9 p.m. and 1 a.m. local time. Mark that on your calendar right now, between 9 at night and 1 in the morning. But the intensity of what you see depends entirely on whether this storm stays at G4 or escalates to G5. And that decision is happening right now, 75 million miles away on the surface of the sun. Let me paint you a picture of what is actually happening at this moment. The sun has unleashed a massive coronal mass ejection, or CME, directly toward Earth. Think of it like a billion-ton cloud of electrified gas traveling at over 1 million miles per hour. That cloud hit Earth's magnetic field just hours ago, and the collision created a shockwave that is literally shaking our planet's protective magnetic bubble. High-energy particles, protons accelerated by magnetic shock waves, are raining down on our atmosphere right now, and this bombardment will continue for at least the next 24 hours. Now, I know what you are thinking. That sounds terrifying. But here is the fascinating part. When these charged particles collide with gases in our upper atmosphere, they create one of nature's most spectacular displays. The Northern Lights, greens, purples, reds, dancing curtains of light that most Americans never get to see in their lifetime, and tonight could be your chance. But do not go anywhere yet, because the story gets even more interesting. Comment below with your city and state, and I will personally tell you your chances of seeing this historic event tonight. Let me give you some perspective on just how rare this is. The last time we had an S4 solar radiation storm was October 31st, 2003. Halloween night, some of you might remember it, the Halloween solar storm. It caused power outages across parts of Sweden. Satellites were damaged, airlines had to reroute flights away from polar regions, and the Northern Lights were visible as far south as Texas and Florida, just like tonight. But here is the twist. That 2003 storm actually reached G5 level, the highest possible rating. And there is a very real chance tonight's storm could do the same thing. In fact, space weather forecasters are watching the data very closely right now, and some models suggest we could hit G5 within the next 6 to 12 hours. So what is the difference between G4 and G5? Let me break it down for you in terms that actually matter for what you will see tonight. Under a G4 storm, which is what we have right now, overhead auroras, the really spectacular dancing lights directly above you, will be visible across the northern plains states. We are talking North Dakota, South Dakota, Montana, Minnesota, also the Northeast, Maine, Vermont, New Hampshire, upstate New York, and the Pacific Northwest, Washington State, Oregon, northern Idaho. If you live in any of these areas, you are in for an absolutely incredible show tonight, assuming clear skies. Now, further south, in a band that includes Oklahoma, Tennessee, Virginia, and Maryland, you will see what is called an aurora glow on the northern horizon. It is not overhead, but it is still beautiful. A greenish glow, like a distant city light, but shimmering and moving. And here is something really cool. If you live even further south, places like northern Florida, near Jacksonville, Dallas, Houston, Phoenix, Southern California, you can still see the Northern Lights tonight. But here is the catch. You will need your phone or a camera. Set it to a long exposure or night mode, point it north, and the camera will pick up lights that your naked eye cannot see. The sensor in your phone is actually more sensitive to certain wavelengths than your eye, so even if you cannot see anything, your camera might capture an amazing display. But what if this escalates to G5? And remember, that is still very possible tonight. Then everything changes dramatically. At G5 intensity, overhead auroras could be visible as far south as Oklahoma City, Nashville, Tennessee, and Raleigh, North Carolina. I would not even rule out northern Alabama or northern Georgia seeing overhead displays. That would be absolutely historic. The Aurora glow line would extend all the way down to New Orleans, Dallas, Fort Worth, Atlanta, and even the northern Gulf Coast. And the camera detection line that would reach into Mexico and cover every single square inch of the continental United States, including Miami, the Florida Keys, and South Texas. Let me repeat that because it is stunning. If we hit G5 tonight, every single person in the lower 48 states could potentially photograph the northern lights. Every single person. Now, are you wondering what causes these different intensity levels? Let me explain, because this is where it gets really fascinating. The G scale, which stands for geomagnetic storm scale, measures the disturbance in Earth's magnetic field. It ranges from G1, which is minor, all the way up to G5, which is extreme. We are currently at G4, which is severe. The rating depends on something called the KP index, which measures magnetic field fluctuations. Without getting too technical, think of it like the Richter scale for earthquakes, but for space weather. G4 means the KP index is at 8, G5 means it hits 9, the maximum. And right now we are teetering right on that edge. But here is what most people do not realize, and this is critical. This is not just about pretty lights. This geomagnetic storm is causing actual, measurable impacts on our technology and infrastructure right now. Let me walk you through what is actually happening as we speak. First, high-frequency radio communications, already experiencing blackouts, particularly in polar regions. This affects airlines flying routes over Canada, Alaska, Greenland, and the Arctic. Pilots rely on HF radio to communicate when they are out of range of normal radio towers. Right now, some of those communications are completely blacked out. Airlines are aware and have backup systems, but it is a real operational challenge. Second, GPS and navigation systems. The charged particles are interfering with satellite signals. Your phone's GPS might be a little less accurate today, but more importantly, precision GPS systems used in aviation, shipping, and surveying could see degraded accuracy. We are talking errors of several feet instead of inches. Third, satellite operations. Right now, satellite operators are putting their spacecraft into safe mode. The high-energy particles can damage sensitive electronics. Over 5,000 satellites are currently in orbit. Communications satellites, weather satellites, GPS satellites, all potentially at risk. Most will be fine, but there is always a chance of damage during a storm this intense. Fourth, and this is the big one, power grids. During the 1989 geomagnetic storm, the entire province of Quebec, Canada lost power for 9 hours. 6 million people without electricity. The cause? Geomagnetic-induced currents, or GICs. These are electric currents that the storm induces in long power lines and transformers. At G4 and G5 levels, these currents can be strong enough to damage transformers or cause widespread blackouts. Now, do not panic. Power companies in the United States are far more prepared today than they were in 1989. They have monitoring systems, protection schemes, and procedures to reduce risk. But the threat is real, and grid operators are on high alert tonight. And here is something most people do not know. If you happen to be flying tonight, particularly on routes that go near the poles, you are receiving a slightly elevated dose of radiation. Not enough to cause immediate harm, but measurable. Pilots and flight attendants who fly these routes regularly actually accumulate radiation exposure over their careers. During an S4 storm like tonight, that exposure rate goes up. Airlines sometimes reroute flights to lower latitudes during major solar storms for this exact reason. Now, let me give you something you can actually use. The weather forecast for tonight, because clouds are your enemy when it comes to aurora viewing. You can have the most intense geomagnetic storm in history, but if you have clouds, you will not see anything. So let me walk through the country region by region and tell you who has the best chance of clear skies tonight, starting in the Northeast. There is a low-pressure system moving through right now, bringing some snow to parts of New York, Pennsylvania, and New England. By tonight, that system will be moving offshore. Cloud cover will decrease, but there might still be some lingering clouds, particularly in Maine and northern New England. However, from New York City south through Philadelphia, Washington, D.C., the mid-Atlantic region, skies should be mostly clear by 9 or 10 p.m. tonight. Excellent viewing conditions. The Great Lakes region, we have some cloud cover right now associated with that same low-pressure system, but high pressure is building in behind it. By tonight, places like Chicago, Detroit, Cleveland should see clearing skies. Wisconsin and Michigan, particularly the Upper Peninsula, you have got a great shot at clear skies, and you are far enough north to see spectacular displays if this holds at G4 or goes to G5. The Southeast. This is looking really good. High pressure is dominating. Clear skies expected across most of Georgia, the Carolinas, Virginia. There might be some scattered clouds over Arkansas, Tennessee, and Mississippi, but even there, I expect breaks in the clouds. So you should get at least some viewing opportunities, Texas and the Southern Plains. Here is where it gets tricky. There is some cloud cover expected across parts of Oklahoma, North Texas, and Louisiana tonight. Not a complete washout, but scattered to broken clouds. Houston, unfortunately, you might have too much cloud cover to see much, but Dallas, you should see some breaks. Oklahoma City, similar situation. Just keep watching the sky and be ready to step outside when you see clearing. The Midwest. Kansas, Nebraska, Iowa, Missouri, this is looking excellent. High pressure, clear skies, and if we hit G5, you are going to see an incredible show. Kansas City, Omaha, Des Moines, St. Louis, you have got winning lottery tickets for tonight. The Northern Plains, Montana, and North Dakota will see some clouds moving in late tonight, early tomorrow morning. But through the prime viewing window, 9 p.m. to midnight, you should have decent conditions. And you are far enough north that even under partly cloudy skies, you will see auroras in the breaks. The Mountain West, Colorado, Wyoming, Utah, Idaho, this is looking fantastic. Clear skies, high elevation, away from city lights if you get out of the metro areas. If you live in Denver or Salt Lake City, drive 30 minutes outside of town tonight and you could be in for a life-changing experience. The Pacific Northwest, Western Washington and Oregon might see some clouds, but eastern parts of those states should be clear. And you are far enough north for excellent viewing. California, Nevada, Arizona, New Mexico. Mostly clear skies expected. Southern California, you will need that camera, but it might just work. Northern California, you have got a better shot at naked eye viewing. Now here's a pro tip that can make or break your experience tonight. Get away from city lights. Light pollution is the silent killer of aurora viewing. Even a moderate display can be completely washed out if you are in a brightly lit area. If you can drive just 15 or 20 minutes outside of town to a dark location, your experience will be 10 times better. And let me give you some practical advice on how to actually see and photograph this. First, give your eyes at least 15 to 20 minutes to adjust to the dark. Do not look at your phone screen. Or if you do, use a red light app or red filter. Your eyes have two types of photoreceptors. Rods, which see in low light, and cones, which see color and detail. The rods are what you need for aurora viewing, and they take time to activate fully. Bright light resets that process. Second, look north. In the United States, that is the direction auroras will appear. They might spread across the sky if intense enough, but they will originate from the north. Third, be patient. Auroras can be dynamic, with lulls and surges. You might look out and see nothing. Then 20 minutes later, there is an incredible display. During a major storm, the show can go on for hours with varying intensity. Fourth, for photography, here is what you need to know. If you have a smartphone, use night mode or long exposure mode. Point it north, keep the phone steady, maybe prop it against something, or use a small tripod. The camera will capture light your eyes cannot see. If you have a real camera, use a wide-angle lens, set it to manual mode, high ISO like 1600 or 3200, aperture wide open like f2.8 or f4, and shutter speed around 5 to 15 seconds. Take lots of shots and adjust as needed. Now let me address something important. Some of you might be worried. Is this dangerous? Should I be concerned about health effects? Let me give you the straight answer. For people on the ground, there is zero health risk from the geomagnetic storm itself. Zero. The auroras are happening 60 to 200 miles above your head in the upper atmosphere. The particles never reach the ground. You could stand outside all night watching and you would receive no additional radiation exposure. However, there are some indirect risks to be aware of. If you live in an area that could see power outages, have a flashlight and some supplies ready, charge your phone, Have some water and non-perishable food, not because I think widespread outages are likely, but because it is smart to be prepared anytime severe space weather is forecast. If you rely on GPS for critical navigation, be aware that accuracy might be degraded. This is mainly a concern for aviation, maritime, and surveying applications, not for driving around town. And if you have any critical medical devices that depend on power or communications, make sure you have backup plans in place. But for most people, the biggest risk tonight is staying up too late and being tired tomorrow. And honestly, that is a risk worth taking for a chance to see something this spectacular. Now, I want to take a moment to explain why this is happening right now. Why this particular week? The answer has to do with where we are in the solar cycle. The sun goes through an 11-year cycle of activity. At solar minimum, the sun is relatively quiet. Few sunspots, few eruptions, few geomagnetic storms. At solar maximum, the sun is active. Lots of sunspots, frequent eruptions, regular geomagnetic storms. We are currently approaching solar maximum, expected to peak sometime in 2025. So we are in a period where events like this become more likely. But even during solar maximum, G4 and G5 storms are rare. We might see 1 or 2 per year at most. Some years, we see none. So this is genuinely a special event. The specific eruption that caused tonight's storm came from a large active region on the sun, a cluster of sunspots. These are areas where the sun's magnetic field is extremely strong and twisted. Sometimes that magnetic field becomes so twisted that it snaps, releasing enormous amounts of energy in what we call a solar flare and coronal mass ejection. The flare itself, which is a burst of radiation, reached Earth at the speed of light in just 8 minutes. That caused some immediate radio blackouts on the daylight side of Earth. But the real show comes from the CME, that billion-ton cloud of plasma I mentioned earlier. That takes 1 to 3 days to reach Earth, depending on how fast it is traveling. This one was fast, which is why the impacts are so strong. And here is something fascinating. We can actually predict these events now. Satellites like SOHO and Stereo watch the sun constantly. When they see a CME erupting, scientists can measure its speed and direction and predict when it will hit Earth, usually with pretty good accuracy. That is why you are hearing about this storm in advance instead of being surprised by it. Now let me tell you about something incredible that is going to happen later this week. And I need you to pay very close attention to this because it could affect millions of Americans. Starting Friday night and continuing through the weekend, a major winter storm is going to impact a huge portion of the United States. We are talking snow and ice from Texas to the Carolinas. And I am not exaggerating when I say this could be one of the most significant winter weather events in years for the southern United States. Here is what we are expecting. Friday night into Saturday, a developing low-pressure system is going to bring a very dangerous mix of freezing rain and snow to the southern plains. Areas like western Texas, including Amarillo and Lubbock, Oklahoma, southern Kansas, and Arkansas are in the crosshairs. Now here is why this is such a big deal. We are not just talking about a little bit of snow. We are talking about the potential for extreme ice accumulation. In some areas, computer models are showing the possibility of 1 inch of ice accumulation. 1 inch, let me put that in perspective for you. 1/4 inch of ice can snap tree branches and power lines. 1/2 inch of ice can down large trees and cause widespread power outages that last for days. 1 inch of ice is catastrophic. It can bring down transmission towers, collapse structures, and leave hundreds of thousands or even millions of people without power in the middle of winter. And here is the problem. The southern United States is not prepared for this. States like Texas, Louisiana, Arkansas, they do not have fleets of snowplows. They do not pre-treat roads the way northern states do. Many people do not have winter tires or experience driving in ice. This is a recipe for a very dangerous situation. By Saturday, the storm will be spreading across Mississippi, Louisiana, Tennessee, Alabama, and Georgia. Heavy snow is expected across Kentucky, Tennessee, and Virginia, with some areas potentially seeing 6 to 12 inches. But the real danger remains the ice, particularly from northern Louisiana through Arkansas and into southern Missouri. By Sunday, the storm will be moving up the East Coast, bringing snow to the Carolinas and potentially as far north as Virginia and Maryland before moving offshore. We are talking about impacts to 100 million people. Travel will be extremely dangerous or impossible in some areas. Power outages could last for days. This is the kind of storm that you need to prepare for now, not when it is already happening. And here is my promise to you. We will have detailed coverage of this storm every single day this week. Potentially 2 videos per day as the storm approaches, keeping you updated on the latest forecasts, track changes, and impacts for your specific area. But right now, let me bring us back to tonight, because while that winter storm is days away, the geomagnetic storm is happening right now. As I am speaking to you, charged particles are colliding with our atmosphere. The auroras have likely already started in the far northern latitudes. Alaska is probably seeing incredible displays right now. Northern Canada, Scandinavia, they are already witnessing the show. And in just a few hours, as darkness falls across the United States from east to west, millions of Americans are going to step outside and potentially see something they have never seen before. The Northern Lights dancing across their sky. Think about that for a moment. There are people alive today who have never seen an aurora. People who live in places like Georgia, Texas, Florida, who assume they would have to travel to Alaska or Iceland or Norway to ever witness this phenomenon. And tonight, it might come to them. That is the incredible thing about space weather. It is a reminder that we live on a planet, a sphere of rock and water and air, floating through space, connected to a star that is 93 million miles away. And sometimes that star reaches out and touches us, not with heat, but with light and energy and beauty. Now, I want to share one more thing before we wrap up, and this is important. Geomagnetic storms like this are not just beautiful, they are also scientifically valuable. Every time a major storm hits Earth, scientists learn more about how our magnetic field works, how it protects us, and how space weather affects our technology. Our magnetic field is what makes life on Earth possible. It shields us from the solar wind, a constant stream of charged particles from the sun that would otherwise strip away our atmosphere. Mars lost most of its atmosphere billions of years ago, partly because it does not have a strong magnetic field like Earth does. But our magnetic field is not static. It moves, it changes, it fluctuates. And during geomagnetic storms, we get to see it in action, responding to the impact of a solar eruption in real time. The auroras are literally showing us our magnetic field lines made visible by glowing gases. So when you step outside tonight and look up at those dancing lights, you are not just seeing a pretty show. You are seeing the invisible shield that protects all life on Earth, flexing its muscles, doing its job, keeping us safe from the fury of the sun. And that is pretty incredible when you think about it. So here is what I want you to do. Right now, comment below with your city and state. I want to know where you are watching from, and I will personally respond and tell you what your chances are of seeing the auroras tonight based on your location and the weather forecast. Set an alarm on your phone for 9 p.m. tonight. When it goes off, step outside. Look north. Give your eyes 15 minutes to adjust. Be patient, and you just might witness something you will remember for the rest of your life. Take photos, share them with friends and family, post them online. This is a moment worth capturing. And tomorrow, come back here, because we are going to have a full breakdown of what happened tonight, the best aurora photos from around the country, and our first detailed look at that major winter storm that is going to impact the United States later this week. Make sure you are subscribed to this channel. Hit that bell icon so you get notified the moment we post new updates, because between this geomagnetic storm tonight and that winter storm later this week, this is shaping up to be one of the most significant weather weeks we have seen in a long time. The next 24 hours are going to be remarkable. A night that people will talk about for years. The night the Northern Lights came to America, and you get to be part of it. So comment below right now. Tell me where you are. Let me know if you saw the lights. Share your photos. Let us make this a moment we experience together, all across the country, all looking up at the same sky, all witnessing the same incredible phenomenon. This is history in the making, and you are here for it. See you tomorrow with a full recap and the latest on that developing winter storm. Until then, keep your eyes on the sky. Tonight